Hello students, I am Dr. Bipin B. Gawande and welcome to video lecture series for engineering graphics. We are discussing about the Radial Line Development Method and we have solved the problems on cone, hexagonal pyramid and pentagonal pyramid in previous video lectures. Now we will take the problems on the square pyramid. Okay, now the square pyramid is something like this. So the true shape is the square. So this is ABCD, the base of the pyramid, and in case of pyramid we have the apex. So this apex is joins with the corners of the square. Okay, so the we get here the triangles. Okay, so since this square is having four sides, so we in case of this square pyramids we get here four triangles. Okay, so this is our square pyramid. This is called as what? The slant edge. And the condition for the radial development is what? We required the true length of the slant edge for the development. Now here the side is given 30 mm. Okay, so this base side is 30 and axis height, so from center O, okay, here up to this one. Okay, so this height is given equal to 50 mm. Okay, it is resting on the base on HP. So this is our HP here. Here we'll get top view and this is our VP. Here we'll get the front views. The problem always starts with the HP and with the top view, and the front view comes in the VP. Okay, the condition is with an edge of the base parallel to VP. Edge of the base parallel to VP. Okay, so there are two positions for the we can put this square. So we can put the square something like this, so on the edge, or we can keep it on the corner something like this. Okay, so suppose this is ABCD and this is AB and CD. So this position is called as resting on edge, this position is called as resting on the corner. Okay, now what is given? Edge of the base parallel to VP. So this edge must be parallel to VP. So this is our VP. So this condition is correct position. This is not. Why? Because all the edges of the base are here inclined to VP, and in the problem it is given the edge of the base must be parallel to VP. So this edge, okay, one edge out of the base. Okay, so here this is AD edge, BC edge also, this is parallel to VP. So this is the correct position of the square in the true shape. Okay, so we will first construct this true shape of this square pyramid, which is a square of 30 mm side. Okay, so this comes something like this. So this is 30, all sides are of 30 mm, like this. Okay, now the nomenclature is, this is A, this is B, this is C, and this is D. Now in top view we know that when we look this square pyramid in top view, so we get here the square ABCD and this O, that is apex. Okay, so it comes at the center and all the corners of the squares it joins with the apex. Okay, so that's why we are getting here four triangles. So this is 1, this is 2, this is 3 and 4. So this is the true shape of the square pyramid in top view. So here it is very simple to find out the center. We have to just join the opposite corners. So you join here the opposite corners and we'll get here the center. So this is our O. Okay, now the axis height is given 50, so axis comes along the projection of O. Okay, so this is 50 mm. Now in this case this is the axis only, because no edge is coming along this axis. Okay, so we have to draw this as an axis and not at the edge. We can draw that as an edge if here any corner point comes here. Okay, so here no corner point is there, only O point is there, so it is an axis. Okay, so now this is the projections of AB and CD. This is our O, this is O dash point. Okay, and the front view is a triangle. So in case of the pyramid, the front view is a triangle. Okay, the projection here, this is the projection is here A dash and B dash, this is C dash and D dash. Okay, So what we have drawn, we have drawn the true shape of the square pyramid, that is a square, and we have drawn the front view as a triangle. Okay, now the first sentence it is over, and the condition also we have satisfied. The edge of the base, we consider, suppose AD is our edge of this base, it is parallel to VP, so this edge is parallel to VP. Now the second sentence, it is cut by the section plane incline at 45 degree to HP. So I have already told you all the angles will come here only in VP. That is, the in VP we'll get section plane inclined to HP. So in all the problems in the development, you have to cut the front view only. So angle is 45 degree. Now where we have to cut? We have to the section plane passing through the midpoint of the axis. So we have to find out the location. So it is midpoint of the axis. So this is midpoint. This is 25 mm. You draw there one horizontal line. Okay, here, and then how much angle? It is 45 degree. Okay, so this is 45 degree angle, and then we have to draw here the section plane. So this is our section plane. Okay, so section plane we have drawn. So section plane is inclined at 45 degree. Now we have to mark the intersections. So how to mark the intersection? If one slant edge is there, we have to mark one intersection. If there are two slant edges intersected by the cutting plane, we have to mark two intersection, and we will mark the intersection alphabetically. So now here this is A and B. Okay, so this is for OA, it is 1. For OB it is 2. Okay, here it is C, so for C it is 3, and for D it is 4. Okay, so we have marked the intersection because here there are two slant edges, O dash and A dash, O dash and B dash. So for O dash and A dash it is 1, O dash and B dash it is 2, for O dash and C dash it is 3, and for O dash and D dash it is 4. Okay, so that is the second sentence of the problem. Now we have to draw the development. We know that the radial line since this is a problem of pyramid, we have to use the radial line development method. But the radial line development method is always we have to draw it on the true length of the slant edge. In case of pyramid, it is on the true length of the slant edge. Now how to ensure this O dash and D dash, or O dash or C dash, it is represent the slant edge. Now whether it is true length, it is denoting true length or not, we have to see whether either OC or OD, if it is parallel to XY in the top view. But here if you see in top view, OC is inclined and OD is inclined, and both are not parallel to XY. So this O dash C dash and O dash D dash, it doesn't represent the true length in the front view. The condition for true length is what? In top view, that particular edge must be parallel to XY, but here both are inclined. So what is how to get the true length of the slant edge in the front view? So we have to make either OC or OD parallel to XY. Okay, so we will take this O center, okay, this OC distance in compass, and you rotate this one. Okay, you rotate this OC. So we'll get here, suppose this is C1 point. Okay, so you rotate OD or OC, so that comes here only. Okay, we got this as a new point, and then you transfer that new intersection, or that new point in the front view. Okay, so now we'll get here. Okay, we'll get this one. Okay, like this. So this is our C1 dash. Okay, so now this O dash and C1 dash, this is our new slant edge, and it represents the true length in the front view. Why? Because OC1 in top view, it is parallel to XY, and the line which is parallel to XY in top view, that line only represents the true length in the front view. So OC is not parallel, OD is not parallel, so initially it is not represent the true length, but now we have rotated that OC and we have made that OC parallel to XY, and we got now the new slant edge O dash and C1 dash, which is representing the true length in the front view. Okay, now the next thing is to draw the development. So you take the parallel line from O dash. Now keep your roller scale on the new slant edge because it is representing the true length. Okay, like this. So this is O, this is our A. Okay, now the remaining method is same. You take O as a center, okay, and this A as a radius, then draw the curve. Okay, now how many divisions here? So we are concerning about the square pyramid. So the square is having 4 sides of 30 mm. So take 30 mm distance in compass. This is 1, this is 2, this is 3, and this one is 4. Okay, so we will join this one, so like this, here, okay, here, and like this. Okay, the nomenclature is A, B, C, D, and the last one is again E. Okay, now we know that in case of the pyramids, the true shape, it is with the edges. So we have to join this with edge. So this is A, B, it represents the edge. Okay, so don't forget to join this by means of the line, because this represents the edges. So here this is CD, and the last one is here, it is DA. Okay, so this is the basic development for the this is for the square pyramid. We got here 4 triangles. Okay, and the radial line development, we have started with the new slant edge. We have got, after rotating this OC, and we have make that OC parallel to XY, and we got the true length of the slant edge here. Okay, so this is very important in this problem. Okay, now we have to transfer the projections now. So transfer the projections on the slant edge. So this is projection 1 and 2, and then this projection is 3 and 4. So this projection is 1 and 2 here, this is 3 and 4. Okay, now rotate the projections now. So draw the curves from this projection. So this is 1, and this one is 2. Okay, now mark the projections now. So 1 is on A, so this is 1. 2 is on B, okay, so this is 2. Now 3 is on C, so this is 3, and 4 is on D, so 4 is on D. 1 is again, sorry, here it is 1 is again on A. So 1 is on A, 2 is on B, 3 is on C, and 4 is on D. Okay, so we got this one. So now join this. Okay, so this is a join 1 to 2. Okay, then 2 to 3, then 3 to 4, then this is 4 to 1. Okay, and then like this. Okay, so this is the development for the square pyramid, when the section plane cuts at a it cuts the square pyramid at an angle of 45 degree at a and the location is what, the midpoint of the axis. Okay, so construct the problem something like this. So this is the required development, which is here. Okay, we have to make this dark. So the green lines, it represents the development for the square pyramid. So something like this. So how we have transferred the projection? So 1 is on A, OA, 2 is on OB, so same projection. Okay, 2. Then 3 is on OC, so this is 3, and 4 is on D. Okay, and 1 again comes on A. Okay, so this is 1. So join 1, 2, 3, 4, and again 1. In case of the pyramids, we have to join all the intersection by means of the lines. Okay, so this is the required development for the square pyramid. Okay, the most important thing in this problem is the construction of this slant edge, new slant edge, which represents the true length, because initially the whatever the slant edge is there, it is not representing the true length, because OC and OD, it is not parallel to XY. The condition is what? If the edge, if the projection is parallel to XY in the top view, then only that edge represents the true length in the front view. So OC and OD, they are not parallel to XY, so initially it is not the it is not represent the two length in the front view, but now but afterwards what we have done, we have rotated this OC and we have make that OC parallel to XY. Then we have transferred that new point in the front view. We got O dash and C1 dash as a new slant edge, which is representing the true length of the slant edge, and then by taking the parallel line to that new slant edge, we have drawn the development. Okay, so this is the development for the square pyramid. Okay, so construct this and complete the problem. So thank you very much.